So in the last class, we were doing concave and convex lenses. Right, we did the diagram of convex lens, that is converging mirror or a convergent lens. And today we will see the diverging lens. Okay, let's start with it. Let's see how the light rays are being reflected or diverged in a concave mirror, okay, and a concave lens. Let's make it.
I have a question, ma'am.
Yes, Abraham.
What is the coordinates of concave?
We are doing
Ma'am,
concave lens.
this
Okay, convex we did yesterday. This is concave lens. Which is also a diverging lens. Which is a diverging lens. Okay. So we have a light ray passing, okay, from here, and here. And what happens? They'll go till here, and then they'll diverge in this direction, like this. Okay. Now, if I extend them, let's use some other color. They will meet each other at this focal point. They meet each other at this focal point F. Okay, and this is where image formation will take place. Okay, and this is how concave lenses work. This is how the rays are diverged. Can you see the diversion? Can you see this ray diverging like this and this ray diverging like this? And they are meeting at an imaginary point F. This is how it happens. Reflection is taking place in a concave lens. Okay, this is how reflection is taking place in a concave lens. Hope this part is clear to you.
Yeah.
Okay. If you want to draw this, you can draw it. Okay.
So it's clear, ma'am. But I have this question, ma'am.
Yes, Abraham.
Magnifying glasses lens will be concave or
Magnifying glasses.
can you just repeat?
What are you asking? Can you repeat the question?
You know, magnifying glass lens. Ma'am, this one be a concave or
Convex. We have a convex, Abraham. In a magnifying glass, we have convex, right? Because convex mirrors focus the light rays at one focal point, right? They are converging. So when you see with the magnifying glass, it will focus the light on that particular point where upon which you are placing it. So it will appear enlarged. Okay, so it will appear enlarged to you because it is like all the rays are only focused on that point only. That is a convex lens which is used in a magnifying glass. Okay, to it makes the object appear much larger. Okay, convex lens. Convex lenses make the object appear larger. That is used in a magnifying glass. Okay.
Okay, so my convex lenses are mostly used for spectacles.
Convex lenses are mostly used in spectacles, yes. But like I said, spectacles are made of both concave and convex. Have you heard this term, दूर की नजर and पास की नजर? Like nearsighted glasses and far-sighted glasses. They are one
Yes.
spectacle.
Yes,
Yes,
ma'am,
for
I
both. Yeah,
And
for
then
both. Only
has
one spectacle.
far-sighted glasses so she could see, so she can see far.
Repeat it. Last line.
Ma'am, I know the near-sighted glasses is because my sister has a one, so she can see far-sighted because so she can see far.
Yeah. Yes. So both types of lenses are used in your spectacles, okay? Concave and convex. Convex for the nearsightedness and concave for farsightedness, like that. Okay.
Ma'am, I have a question. If they're not
Yes.
to see close, they will not be able to see far even, right, ma'am?
If they are not able to see close, they will not able to see far. Some it happens for some people, yes, but there are some people who are also able to who are able to see far, but unable to see close. They only have problem in seeing close, okay, but they can see far. That is like basically depends on the image formation on our retina. Okay, that depends on the image formation. Sometimes the close images are not formed properly, but the far images can be formed. So to correct that, they are given a convex lens, okay, only, so they can see the far close images, but far images they can see without the glasses.
What is
That
the M and
M and N is are the 2 points of the glass, sorry, the lens. Okay, basically the name of the lens.
what is the full form of that?
Full form, no full form. It's just M and N. MN is your lens. Okay, MN is your
Excuse me, ma'am. That's there
yes.
for all the lenses.
That's
All
there for
these
all.
diagrams you draw, could you please share it in the group?
Okay, I'll share it in the group.
Thank you.
So these are the mini diagram. When you took the
um, when I took the
teacher to science, when you took the test, you didn't send any of the diagrams.
last test, it didn't had any diagrams. Crop production chapter was not having any diagrams. Okay, yeah, that is why. Yeah, and I haven't given any diagram in the test also because there were no diagrams. I checked, but no diagrams for that chapter. That's why I haven't sent. Okay, yeah. So, concave lens we did, that is diverging lens, which diverges the light rays, convex converges the light rays. Okay, then we will do the sunlight. Okay, sunlight, what it's made up of, what color is it, okay, and all of that. So,
When it said
yes,
put the magnifying glass like in the sun, and when you leave it over there, like it's very hot, it will cause fire.
It will cause fire. Yes,
Is it because like the convex lens is converging all the sun's rays at
yes,
one
yes,
point?
yes, because it's like converging all the sun rays at one point. That's right, Eva. That is right. Like if you place a paper, okay, and then you put magnifying glass over it and the sun is falling on the magnifying glass, then you'll see a hole will start burning. Okay. But it doesn't burn the entire paper. Okay. Only at a particular spot it starts like blackening little bit, brownish and blackening little bit, right? Because the convex mirror is focusing all of that sunlight at that point.
Mom, but I read in my other science book that if it's like a hot sun and you put it on a pavement, the entire tissue will burn out.
Um, Tissue, I think so. It will like it will burn out, but like first it starts from one point. Like the whole thing doesn't catch fire all at once. Right. It starts happening from one point. That point is the focal point where it starts happening. And then it slowly spreads. Okay. If it's for a long time or too strong sun rays, it will slowly spread out to the rest of the paper. Okay. Why do the lights diverge? Light rays diverge. 1 second. In a concave, what makes it diverge? What makes it diverge?
With less composition, it will burn the entire thing, right? Because it's like less
It will burn slowly. It will burn the entire thing. Okay, slowly it will burn the entire thing. Okay, what is in it? See, Simeon, what is the difference between a concave and a convex mirror? Okay, the concave mirror
Concave curves inward.
inwards and convex curves outwards. So basically, that is the reason why the rays falling on the concave mirror diverges. Okay, this is mainly the reason why it's diverging. Okay, because of its reflective surface, because of like that its reflective surface is inwards. That is why the rays basically diverge. Okay. Um, is the curve is the rays? Yes, yes, that's right. The curve will bend the rays. Okay. Yeah. Now moving on to sunlight.
and convex lenses are the reason of projection, right, ma'am?
Projection you're talking about.
Yes, ma'am.
Projection, I think so, yes, that convex are used.
It's because when I take a magnifying glass and keep it near the phone in the dark, an image will come on the wall.
Mm-hmm. Yes, that is right. Okay. So, sunlight. Now, these are like the concave and convex experiments you can like keep on doing and keep on noticing too. You'll find a lot of daily examples, like in your everyday life, you'll find a lot of examples of converging, diverging lenses. Okay, like um, the side glass of a mirror, your spectacles, you can find out like if it's concave, convex. Okay. The convex will have a focal point, will focus on one thing, but the concave will cover a wider surface area. Okay, it will cover a wider surface area. So that way you can see and define the if it's a concave or convex. Okay, then we have sunlight. We all have seen rainbow in the sky, right? After the rain, right? We've all seen a rainbow. Now, how is it formed? It is formed when sun is near to the horizon. Rainbow is seen as a bow of multicolor. We know how many colors are there in the rainbow? 7. Yes, 7 colors are there. That is with your violet blue, indigo, green, orange, yellow, and red. Okay, those are all the colors in a rainbow. Now, what happens basically? These all colors, like when they are together, they form a white light. Okay, white light they form. But when this white light spreads out, it spreads out in these 7 colors. Okay, it spreads out in these 7 colors. You must have seen colored bubble on a soap. If you've noticed, a colored bubble on a soap, like when the bubbles are formed, they're like you can see pink and bluish some color. And if you have seen a CD in sunlight, you can also see pink, purple, blue colors on the CD because light is reflected from the sun on the CD. Green, green, yeah, green, Abraham, yes. So, yes, green also. So, we can see like when the light is reflected on these surfaces, on the CD surface, we can see all the colors forming. Okay. Now, basically what happens is that the white light is composed of all these 7 colors. Okay. Now, white light is composed of all these 7 colors. When it disperses, okay, we can see all of those 7 colors. We can see all of those 7 colors. One diagram I'll show you. 1 minute.
Ma'am, like if you want a ruler in a form of sun, like sometimes you will just see like some rainbow coming out.
What do we put in a sun?
If you like hold your ruler to a certain angle when it's facing the sun, you will get sometimes like a rainbow.
Ruler, yes, yes. When we put it in the sun, we will get something like we could see the colors, right? This diagram will show you.
Ma'am, the color is the reason why we like the sunlight is the reason why we see color, right?
Basically, yes.
It's because when the white light shines on the thing, only that
Mm-hmm.
color, that is the color of the object, bounces and goes to our eyes.
Mm-hmm. Yes, yes, Abraham, that happens. That is right. Okay, now here is a white light. You can see that's going in from one side of the prism. Okay, and reflecting on the other side, it's reflecting the rainbow colors. On the other side, it's reflecting the rainbow colors. In your book, only this diagram is given in black and white. Can you imagine? They have given this diagram in your book, black and white. So that's why I had to open this and show you all how like the colors are, all the colors are reflected. The 7 rainbow colors are reflected here. Okay, you can try this out at home with your scale or any object similar to this in the sun. And on the opposite side, when the light passes through, you will see the 7 colors.
Ma'am,
Okay.
magnifying glass,
Magnifying glass. Try it out once with a magnifying glass. Okay. Try and find it out today. All right. 1 minute. Yes. So, the light emitted by the other surface should either fall on paper or wall. You will find color like rainbow here. This proves that sunlight has several colors. Sunlight has several colors. Can a non-triangular shape be used as a prism? Yes, Indian, it can be used. Like a ruler, suppose. A transparent ruler can be used like in the place of a prism. Okay, even if like try using it if you have a piece of glass, okay, or something similar, you can try it out with that too. Okay. A plain piece of glass also I once tried and like it happens. Okay.
Any shape.
Yes. Um Basically yes, but it should be reflective, transparent. Okay.
And
It should be like why does it?
why does it separate? Is it like concave to diverge all the waves?
Why does it separate? Um, Basically, it separates due to the angles of incidence and angles of reflection. Okay, it separates because of those incident and reflective angles that are being formed here when the ray is being reflected. Can you see the angle of reflection that's forming in between the rays, right? Due to this, they diverge. Okay, and when they diverge, we can see all of those colors.
So if you pass a white light through one prism and then that light goes through another prism, will it become white again?
Will it become white again? Mm, I think so. Um, I think so, Samir. I'm not sure.
Keep a
Haven't
glass
tried
ball
it.
upside down and you try to put a light from one side to the other side. It's passing through the glass twice, right? So it will happen like it's a white light again, right?
It's a white light again. Probably yes. Okay, you can try this out and let me know. Okay, probably it will be a white light. Okay, now can we get white light by mixing all these seven colors? Yes. So this is what you are talking about, that one side we have like done the reflection. Okay. And here seven colors are reflected. Again, you put a reflective surface in that. So through that second one, you'll get a white light. Try this out. Try this experiment out. But there's also one activity that's there to prove this. That if we merge all those seven colors once again together, we will get a white light. Okay, that is for sure. That is definitely. When you are merging all those seven colors again, you will get the white light because the white light contains those seven colors. Now, what is the activity? We will take a disc, 10 centimeter radius, and we have divided the upper part into seven sections. You can see that it has been divided into seven sections. Okay, and seven colors. They colored it with seven colors. Okay, and then after coloring it with seven colors, they place it in a metal rod like this or any stick or rod. Then they rotate it. They rotate the disc. Okay, and you will not see the seven colors. You will see white. You will see white.
But
Have
if
you
you
ever noticed
carefully look in the
um,
picture, it looks like the seven colors.
in this picture?
Yes.
No, it will look white. Like in this picture, it's like looking a bit colored, but it will originally look white. Have you, what I was saying, yeah. Have you ever seen a lot of colors moving very fast in any ride or something that you watch, or any scene, any TV or something? A lot of colors when these they move very fast, they'll appear white to you. Okay, they will appear white to you. All right, like notice it sometimes if you see, you'll find that they're passing in a like speed, they'll appear white to you. That thing only is there. The disc, okay, they divided it into 7 parts, colored it in 7 colors, and then rotated so it will appear white to us. Means that the seventh white light comprises all the 7 colors. If we again combine the 7 colors, we get a white light. Okay, this is the effect of sunlight. Okay, this diagram is important. I'll send you the diagram, English diagram for this. Okay, whenever you are asked a question about explaining the sunlight and how the sunlight comprises of 7 colors. If you have a get a question like that, you can show it with the help of this example or this diagram. Okay.
Will any perfectly transparent item work as a prism or only glass?
Will any perfectly transparent item work as a prism? You try and check out. Okay. Try and check it out. Glass I have tried out. Scale I have tried out. Scale is not really a glass, okay, but a transparent material. And with scale it works. Protractor also it works. Okay, like with protractor, we used to try scales and protractors. So it works with that. Try out that does it work with other fully transparent material. Okay. Yes. So all right. Then we have exercise 17.3.
This one.
This you have to try out as a homework.
Ma'am, which
Yes,
is the
Abraham.
blue?
Which blue?
Yes, ma'am.
Um, it's the dark blue, Abraham.
Yes, ma'am.
Let me see again.
And ma'am, is there a way to differentiate between indigo and blue?
Between indigo and blue. One is a little purplish and one is proper blue.
Yeah, indigo is a little purplish. It's like dark purple.
The center one, I think, will work as the indigo. Yes, indigo. Okay. And blue is the actual blue.
Thank you, ma'am.
17.3 is the homework. Okay, structure of human eyes. We'll start this topic tomorrow. We'll go through the diagram. We'll understand how the image forms on our retina. Okay, how we are able to see through our eyes. How does it work? This thing, because less time we have, so I want to start this fresh tomorrow. Okay, have you completed the quadrilaterals part in math? Any doubts?
Ma'am, most of the questions I think you've already done with us.
I have
Yes.
doubt, ma'am.
Yeah, most of the questions I have already
I
covered in
had
the
one
class.
doubt. So they were asking in one question, draw a square with an area of 9 centimeters, and I drew a square with 3 centimeters for each side, but my mother was saying you have to find out how to prove it.
Ma'am,
How to prove it?
how you draw
Yes, Ekta.
centimeter to simian, basically you have to find the half of 9. So it goes into a lot of decimals. If you want to, you have to divide now 9 by 4 and then you can draw it with 9 centimeters as a perimeter.
Okay, but I haven't given you a question about finding out the area. Extra questions you were trying out, Sonia?
I was doing the in-text questions as practice.
In text questions practice. Okay, let me open it. 1 minute.
Ma'am, will you be taking question? Will you be giving us questions on area?
No, I won't be giving questions on area. I didn't saw any question like that. I don't know. In quadrilaterals chapter. 1 second.
So, do we have to practice only the questions you sent us? Because that's the type of questions you'll be giving us.
In text questions also please check out 13.1.
Right, but for practice, like to understand the test, the questions you have sent, that type of questions you'll be giving.
Yes, the questions I have sent that type, and also I can give from your book as well. Okay, from your book that is 13.1, 2 and 3. Please practice that too. Which questions, Simeon, is it? From the in-text questions? From the exercise, it must be, no? I cannot find it.
In the exercise, question
Question?
3 from the exercise.
Okay. All right. So we are given that we have to draw a square with an area of 9 square centimeters. Right. So first we'll determine the side, okay, the length of the side. Now the area of square we are given. Now to find out the length of the side, we can do the root of 9. Okay, that is equals to 3 centimeter. That's equal to 3 centimeters. You have to write this down again. That first we are given that the area of the square is 9 square centimeter, and we will determine the length of the side. Okay. For that, we will take the root of the area. Okay, to find out the length of the side. We get it 3 centimeter. Now you will make a square of 3 centimeter. Okay. You can write now. We will draw a square with each side measuring 3 centimeters, and you will measure the sides with 3 centimeter and then draw the square. Then you can just write at the end that the square of sides 3 centimeter has an area 9 centimeter square. Okay.
Okay. Okay, thank
So
you.
like that you can, like that you can verify and write it down. Okay. Hope you all have understood it. Am I Abraham?
Yes, ma'am. I'll just look through the question. I looked through the exercise ones, the ones you sent, and I didn't have any doubts in that.
Okay.
Just
Okay.
the
Just
first question, ma'am. Just the first question. You sent a question by saying that the rectangle or square. I don't know what you said. You said it had three acute angles, and they measured 80 degrees. And we have to find the measure of the fourth angle. So will the fourth angle be 120 because the other three angles are adding up to 240?
Yes, three acute angles, each measure 80. So you add all the three 80-degree angles, okay? It
You're
will
getting 240 by
be
that. But then will
240,
the
yes.
but
Fourth angle,
mom said that how if the other three are 80 degrees, how can this one be 120?
360 minus 240 because the sum of like the sum of all the four angles is 360. Three angles is 240 and one is 120, right?
Okay.
120, yes. How can it be 120? This is like maybe it's like another kind of quadrilateral,
Okay. Because
like
no, she's just
maybe a
wondering
kite
that
or
if
something.
the other three are 80, how can this one be an obtuse angle?
Hmm. Yes, I get it. Maybe it's a trapezium or a kite or something, like a bit different parallelogram, right?
Okay, thank you.
Yes. So that's fine. Okay. Now, we will stop here. Okay, I'll send you the paper at 3 p.m. today. Okay, just go through the book questions as well in text questions.
Ma'am, ma'am,
Okay.
I have a question.
Okay. Yes.
Ma'am, when you ask for like paper, will you like send us like will you like will you ask area and perimeter questions?
Will I ask area perimeter questions? If I ask, it will be just like the question Simeon has asked. Okay, not too complicated questions. Okay,
Ma'am, can you just repeat how
because
you ask, ma'am?
will I repeat? Yes. I said that if there will be a question on the area, it will be a basic question. Okay, basic question on the area. Okay, because I haven't really done area perimeter questions with you in class. Okay, because that's a bit extra, like a bit higher level. You are going to do it in the upper classes. Okay, I covered the questions which are like required right now on your level, according to what we studied. In your book, it's like only theory of quadrilaterals, but some practice questions I wanted to do with you so you can understand how can we calculate the angles. So area questions, I have not really made the paper right now. So, but yeah, don't worry, it will not be any complicated area or perimeter question. So that's fine. Okay. Okay, then I'll see you guys in the next class.
Okay, ma'am. Thank
Bye.
you. Bye.
Bye. Bye. Bye.
Bye. Thank you.
Okay, bye, so
Oh, okay.
okay, bye.